Assalamualaikum warahmatullahi wabarakatuh. Good morning and salam sejahtera. Yang berbahagia, Academician Datuk Dr. Tengku Muhammad Azman Sharifuddin, President of the Academy of Sciences Malaysia, also serve as the Science, Technology and Innovation Advisor to the Prime Minister and the Nation. Yang berusaha Puan Hazami Habib, Chief Executive Officer of the Academy of Sciences Malaysia. Yang berusaha Encik Muhammad Rizatuddin Nur Muhammad Ramli, Director Investment Department of Northern Corridor Implementation Authority NCIA. Yang berusaha Dr. Hari Narayanan, Chief Executive Officer Penang Skills Development Centre. Yang berusaha Ms. Kor Swee Ha, Senior Vice President, New Technology and Development Inari Technology Sdn Bhd. Yang berusaha Dr. Lee Hing Wah, Head Semiconductor R&D of MIMOS. Yang berusaha Ms. Masni Muhammad, Executive Director, Investment, Policy, Advocacy, Manufacturing MIDA. Fellow and members of Academy of Sciences Malaysia, Management and Senior Officers of Northern Corridor Implementation Authority NCIA, members of industry, respected guests, and fellow audience. Ladies and gentlemen, welcome to the 2024 ASM Northern Chapter Roadshow. I am Siti Sarah, your MC for today's program. As a statutory body established by an Act of Parliament, ASM is under the purview of the Ministry of Science, Technology and Innovation MySTIE. ASM strives to be the thought leader for the nation on matters related to science, technology, innovation and the economy. We provide platform for exchange of ideas among academia, policymakers, civil society and industries. The 2024 ASM Northern Chapter Roadshow is the third roadshow after Sarawak Chapter and East Coast Chapter. These roadshow series are organized to ensure ASM's roles are effectively communicated to our stakeholders across Malaysia. ASM's expert network and programs are introduced during the roadshow to the scientific community, professional bodies, and the public. We would like to thank you to the Northern Corridor Implementation Authority NCIA Malaysia for becoming our strategic partner and making this event possible. Ladies and gentlemen, please join me in welcoming the President of ASM and STI Advisor to the Prime Minister and the Nation, Academician Dr. Tengku Muhammad Azman Sharifuddin, to deliver his opening note.
Bismillahirrahmanirrahim. Assalamualaikum. Good morning. Salam sejahtera. Welcome to this event. Let me just mention a few names that you have to recognize this morning. First, Alhamdulillah for this event. I see people are very excited, just like last night when we had a dinner just down the road from here. People were talking non-stop, a very noisy room. So scientists can be very creative when it comes to talking. Anyway, let me recognize Puan Hazami, our CEO. I always say that she's the one who does everything. I just talk. After that, she does it. Very powerful lady. Saudara Rizatuddin of NCIA, whom I've known for more than 20 years. He was spent 18 years in MDC, MDEC now, a project that I actually worked on in the 1990s, Multimedia Super Corridor. Dr. Hari, another good friend, is going to chair this event later. Very much a friend of ours, worked for Motorola and other places as well, and certainly a good friend of MIMOS after I left. Dr. Lee from MIMOS, our main speaker, because we like to hear from you, from the R&D side, semiconductors. Puan Masni from MIDA, we were sitting next to each other last night. Certainly we had a good conversation on what we could do together to move industry forward. fellows of the academy, management, and officers at NCIA for being here. They are our strategic partners here. And of course, ladies and gentlemen, all of you, most welcome and thank you for spending time. This is the sixth stop for us from ASM. We are touring the country. We started with Sabah, then we went to Sarawak, then Terengganu, Kedah, Kelantan last week, now here. Why is this happening? We are here to listen. If we have to advise the country and the Prime Minister, we have to know what's happening on the ground. So we're not pretending that we know. You know better than us. So we listen to you. In Penang, we have met so many people. All the discussions have been very positive. We have so many ideas now on how to actually focus on Penang as a special case, because we are now talking about change. To keep repeating the mantra, change is the only constant. And in Penang, Penang has been at the forefront of change and should continue to be so. Why has Penang become so special? It is the first location of the E&E industry, and the Penang Chief Minister at that time, Ton Lim Chong Yu, was the one who actually started the ball rolling. Without his visionary decision, with a political will to make it happen, all this would not be possible. So Penang now has the benefit of geopolitical forces pulling many countries to our shores, but we must make our own effort to make this environment better for the sake of the country and for the sake of the industry. What we can do together is actually to look at how we can transform Malaysia into a knowledge-based economy and society. Because the future is no longer the production of material goods. It will become a standard procedure, a process to produce physical things. What is more important is knowledge, and you can see the beginnings of this knowledge revolution from the ChatGPTs of the world. But I claim that ChatGPT does not understand Malaysia, nor does it understand China, nor does it understand India. To give you an example of how China is handling it, I just discovered big AI. Have you heard of big AI? So many of you have not heard of big AI. Big AI is Beijing Institute of General AI. That's big. Big idea. The big idea from China. What they're trying to do, I would say two things. One is to make the AI understand China. I don't think we can accept the fact that ChatGPT is trained on Western data and then claim to know us. So Western data will describe us in their own terms, right? And that's why I mentioned to my friend, Mr. Tan, last night, this is an Anglo-Saxon AI. What will the Chinese do? The Chinese will train their own data, on their own data, and then will manifest Chinese culture and civilization. And so should we. Why do we leave it to ChatGPT to do it? That's one. Another one is the amount of energy being used by companies to train AI engines is just huge. I saw a number the other day which was shocking, and I couldn't figure out. It's 5% of the world's energy. Have you heard that number? 5% of the world's energy is being used to train AI engines. And it's creating a lot of carbon dioxide in the air because all these plants are using fossil fuel. Just imagine what the greenies will do. I cannot use your AI engine because it's destroying the earth. Another interesting possibility. For ESG is real. So these are the things that matter to us. When we look to the future, it is not merely following the path of those that are on the path already. Why do we go off the beaten path? Create our own path. And this is the idea that we want to bring to the table here. How do we create a different path at the same time consistent with what's happening around us? So what we can do is to turn a crisis into an opportunity. It's a crisis. Anyway, let's go back to what the event is all about this morning. The MySTIE, my means Malaysia lah, .my. By the way, we actually registered the CCTLD.my in 1987. We were the 16th country in the world to register Malaysia behind Switzerland. And remember, there are 200 countries in the world. We were number 16. How does that happen? Because we were not on the beaten path. We were on the other path. And can you imagine who helped us to create the first internet in Malaysia? Vincent Cerf, the co-inventor of the TCP/IP protocol. He was in contact with us. At that time, you couldn't buy a Cisco box. So what did we do? We created our own. We bought a standard box and programmed it to become a router, internet router. So all these things were done in the 1980s. How come you guys are not creative anymore? I'm asking a rhetorical question, right? You have to move forward. Anyway, the 10 by 10 MySTIE is actually an innovation by us. STIE means Science, Technology, Innovation, and Economy. We added the economy just lately, 3-4 years ago, to stress that science, technology, and innovation alone is not enough. It must impact the economy, our society. So the 10 by 10 matrix is actually on the rows, 10 strategic technologies. On the columns, 10 socio-economic drivers. How they came about was one of our fellows, Professor Mahendran, who is actually an econometrician. He looked at what we had done before on emerging technologies. That was done a few years ago. And he figured that if you can link those strategic technologies with socio-economic drivers, you can come up with a framework for decision making, so that we can move forward on, call it comprehensive and integrated development. That was the idea. It became so compelling, that integration of the two sides, that the government accepted it. The report was put on our website. I just mentioned to my friend, Mr. Tan. It is the most popular report downloaded from our website. 13,000 downloads so far from around the world, more than 70 countries. I'm asking, yes, 13,000 downloads from 70 countries. And countries are now seeking help from Malaysia to help them, their own countries, do the same thing. So, but we have to give a little bit of qualifier lah. Malaysia ni sangat bagus buat blueprint, buat strategic plan ni. Tapi when it comes to implementation, tak begitu bagus. Kita tak pandai buat kerja sebenarnya. Jadi di sinilah, I hope we get to the really bottom of the barrel to figure out not merely the thinking process, but the how to do. Just to mention, we presented a framework for innovation just a couple of years ago to EPU, our customer, our clients. They look at it, very good. You have told us how to do. Can you help us how to do the how to do? This is the nature of what's in our system. And I hope you companies here, you guys know how to do the how to do. In the government, they said so, they didn't know how to do it. It is new kind of, I would say, process and another structure that requires a lot of thinking. Anyway, let's move on. We have had two earlier panels. One of them, the first one was on census in this series. I didn't attend that one. I was tied up somewhere. The second one, I was there. It was on AI. So I actually gave an opening speech like this one, to explain how I saw AI in the same words that I used at the beginning. I do not see AI as compelling at this stage. I don't use it myself. I think better than AI. That's why I claim. The AI can give me all sorts of silly results, but I don't want to waste my time. Okay. When we're talking about number 3 here is on smart technologies and systems. Certainly, we want to hear from you how Penang Northern Corridor can become a hub for these technologies. Tell us what you think. Then we can figure out how to do it together with the other partners. By the way, I can say that after a number of efforts, the CM has agreed to see us for 5:30 this evening. So when we meet him, I can summarize what we hear from you. I'm just expressing your views to CM. So say what you want. Let me just say that as far as ASM is concerned, to repeat, we are here to listen. We are not going to prescribe for you. Even the moderator is one of you, Dr. Hari, you are PSDC. Tell us what you want. We can figure out afterwards. So I want just to mention quickly, because last night I spent a bit of time giving a little speech to introduce to most of the audience the notion of post-normal times. This notion has been used by the Prime Minister. I cannot go deeply into it, but post-normal times implies that the current norms are no longer relevant, no longer workable. They have become obsolete. New norms will be created for a new kind of world, the future, where we will have a different kind of lifestyle. And this is under construction. So new norms do not exist. The old norms are being destroyed. In between, you can imagine what's happening. It is utter turmoil, utter chaos. We have to rebuild this sort of environment so that stability becomes the norm again. But right now, it is very, very unstable. Everything is unstable. Everything has been, I call it, fragmented and shattered. So we have to figure out how to move to the future world. All right. So let me just end by thanking everybody, especially the panel members, the moderators, of course, participants. And we look forward to hearing from you and to a very exciting and creative discussion. Thank you.
Thank you, Dr. Tengku, for the opening speech. Ladies and gentlemen, we will now begin the first agenda of today's program with 1010 MySTIE Technology Series entitled Next-Generation Semiconductor Industry, Smart Technology and Systems. ASM introduced the 1010 MySTIE Technology Series and Innovation Kopitiam in 2023. This event serves as a platform to bring together the scientific community, industry, professional STI bodies, and the government to explore and discuss ways to strengthen the innovation ecosystem, build impactful technological capabilities, and forge impactful collaboration. Before we begin the first session, I would like to introduce our moderator, Dr. Hari Narayanan. Dr. Hari has over 35 years of experience in both industry and academia. With over 20 years of experience at the Motorola Solutions, he has led the R&D organization and served as the managing director for Penang operations. Dr. Hari transitioned to academia in 2019, joining APU as Senior Director of Organizational Development. He later became the Vice Chancellor in 2020 and President in 2022. Now, he is the Chief Executive Officer of Penang Skills Development Center, PSTC, and continues to lead the initiative to enhance talent supply from universities for the E&E industries. Without further ado, I would like to pass the floor to Dr. Hari for our first session today. Dr. Hari, the stage is yours.
Morning. Morning. Now, before I start the panel discussions and so forth, just my personal, just my congratulations to ASM, because for a long time, although I was in the academia and industry, I knew what ASM's kind of, stood for, but I never got to understand, although I was working in Dato Asma a couple of years ago, and she used to talk to me about it. And I felt that at the time, whatever the academia was doing wasn't too close to the industry, and you carry a lot of brains in the academia. And congratulations to the leadership team of ASM to bring such events closer to industry, because that's the only way that we're going to continue to grow in this country. So congratulations to all of you. Thank you. I have a script to follow. That's what they told me. Sometimes I don't, but let me try to do that. Again, Sarah, thank you for the kind introduction about me. I think most of you know it's like coming back home after 4.5 years in Kuala Lumpur. So as Sarah pointed out, and also Tunku pointed out, today's theme is Next Generation Semiconductor, Smart Technology and Systems. And we have two parts to this before lunch. One is the panel discussion, and we have got esteemed speakers today with me. And then later on, we will do the innovation Kopitiam, which is, we will have some of the participants here to share their thoughts in this particular area. So without much ado, let me please welcome our esteemed panelists for today to take the seat. So let me start off with our first panelist for today is Ms. Koo Siew Har. Let me just give a brief about Siew Har. I think this is the first time we're meeting physically. I think Inari has been keeping quiet, keeping all these secret recipes within Inari, if you want to call it. Siew Har serves as a Senior Vice President of New Technology Development at Inari, bringing over more than 35 years of distinguished experience in semiconductor assembly manufacturing and new technology development. Her expertise spans new products, processes, materials, technologies, and packaging development within the semiconductor assembly and packaging industry. Prior to her tenure at Inari, Ms. Koo held key roles at On Semi in Seremban. That was the ex-Motorola, is that right? Okay, yeah. And also, let me get it right, Inter and Stets Chippak, is that right? Yes, in KL. She holds a Master's of Engineering degree from NUS, Singapore, and a Bachelor of Science degree with honors from USM Penang. The topic of her presentation is Advanced Packaging, Driving Industry Innovation. Let's hear from her. Siew Har.
Hello. Yeah, good morning, ladies and gentlemen. Firstly, I would like to thank the organizing team. What they have put up today looked like a simple gathering, but actually a lot of groundwork, I know. We actually, for this presentation, there were already like 3 meetings in preparation, and I'm sure many more by them. So first, I'd like to share on this, I would say, definition of advanced packaging so that we are all on the same page. And then talk a little bit more about the what are the types of packaging that we consider advanced. Maybe before that, I should really do some due diligence to my company. Some may not know, so just in case. So Inari actually is an OSAT. OSAT means assembly, outsource assembly and test company. So we are actually the biggest technology company listed on the Bursa. Okay. Okay, now let me move on. Okay. So, this is a little bit high tech, I think, for me. Okay, I think as most forums that you would go to, let's begin by looking at the market, where it's driving to. So from this chart, actually, I got it from Yole. It was presented recently. Maybe some of you might have attended by this Dr. Tan from Yole, my lunch partner. So you can see from here that actually in the last 2 years, 3 years, the overall total revenue for the market has been in the range of more than 500 billion. And going in the next few years to 2028, as in this chart, okay, is expected to grow to 800 billion. And by early of next decade, okay, it's expected to reach 1 trillion. Okay, that's like double in less than 10 years. And the average growth rate is 4.5%. So 1 trillion, where is this semiconductor device growing? Right? Yeah, so these are the growing market segments. Actually, sorry, I should have pointed out too. From Yole, okay, you can see on the right-hand side, mobile. Mobile is a big proportion of the market, but then it will be stagnant from their forecast over the next, 8 years or so. And computing is also a very big portion of the market, but then it's still stagnant. So where's the growth? Okay, the growth, as you can see here, is actually in the servers, data centers, and therefore AI. We all know, right? AI. And automotive, EVs, and maybe the standard ones, the combustion engine. Automotive also very big growth. So that's from Yole. Right. So these are all the growing markets, and therefore we say they are the technology drivers. So where are we moving in terms of technology? At the bottom, you can see, okay, to serve all these market segments, right? In terms of semiconductor device making, in terms of packaging of these devices, we all need to meet this higher speed, higher performance, higher bandwidth, more functionality within the same area. We need to integrate the system and put in more sensors and memory. And we need to reduce latency, power, and of course, cost. So how do we improve all these device performances, right? So you need to put in, to get the performance, of course, you need to put in more transistors per silicon area. And currently, we know the best fab node actually is down to 1.8, okay, nanometer. So in the range of 2 to 3 in production now. And capacity, as you read in the news, they are fully booked, right, for the next 2 years. But today, the topic is about advanced packaging. We are not talking about device making, right? As in fab. Yes, the best fab in the world is not in Malaysia, not in our region. But can we have the best advanced packaging in Malaysia? I think we have potential, right? We have been in packaging for 50 years, 40, 50 years in the industry. Oh, okay. So More transistors in the silicon area means more expensive, lower yield, and capacity concern, as I said, because only the best fab can do that, right? And to serve the higher performance, the market has been moving for some time into system of package, system on chip. Sorry, system on chip, right? But system on chip means you put the whole system in a chip. It means that some of the functions may need a very high node, okay, very small line and space width. But do all of the functions need such very fine pitches? Answer is no, right? So yes, you can do system on chip. Design-wise also is very difficult. So in the last maybe 3 years, 5 years, you will see a lot in reports and conferences about chiplets, heterogeneous integration. So really, chiplets and heterogeneous integration comes from partitioning. I'm having a little bit of a control problem here. It comes from actually the partitioning of the big chip, the system on a chip, into smaller chiplets where they are connected together through heterogeneous integration, like on interposers or packaging substrates, which I will talk about more later. And therefore gives rise to the birth of advanced packaging. Okay, so advanced packaging, we have 2D, 3D, 3.5D. What's 3.5D, right? We don't hear of 3D dimension, but we don't hear of 3.5D. But this is just a terminology coined for 2.5D and 3D added together within a package. So 3.5D. But anyhow, I will go through a little bit more on this definition. So there you go. At the bottom, you can see everything, the whole system on a chip, now desegregated, partitioned into chiplets through heterogeneous integration. And very important, see the word interposer, right? This is something that Dr. Lee and I have been talking about, planning out very intensively, interposer. So there are many definitions of advanced packaging. You can search around, but I think the easiest one to remember is that given by John Lau, okay, a couple of years ago, that advanced packaging is really the packaging of 2D and 3D IC. So when we say 2D, we mean putting multiple chips side by side. Okay, and 3D, of course, we have some level of stacking. But even that, 3D can mean we have been doing 3D maybe more than 10 years, 20 years ago, 3D stacking. So what's the difference between the current 3D and the old conventional or traditional 3D? I have a slide to show this, basically coming from John Lau. So back on the definition, advanced packaging means multi-chip, not single chip, therefore, package substrate or fan-out RDL substrate, and therefore not metal lead frames. Okay, he did not very clearly specify it, but if you see in the literature and in all the definitions that you can get, typically it will involve flip chip. So flip chip is another enabling technology in advanced packaging. And I like this one also. Basically, when you talk about advanced packaging, especially on the 2.5D and above, 2.5D, 3D, we would typically involve the semiconductor fabs. That's the reason why in Malaysia, knowing ourselves, being weak in the fab arena, we are not so, I would say, ready for the definition given in this Wikipedia, okay, where the back end of the fab is involved. So I would think let's stick to this multi-chips, package substrate with fan-out RDL and not lead frame type, flip chip type and not wire bond type, right? So this is what John Lau has defined advanced packaging. You can see in this red box, okay, multi-chip, and it can go from 2D to 3D, even 2.1D, 2.3D, 2.5D by its definition. Okay, 3D is just multi-chip side by side on a substrate, right? And then if you have only one die, even though it's flip chip, then it's a single chip, it's not advanced packaging. And if you have other intermediates like thin film with a bridge, organic or inorganic with a TSV, no TSV, okay, they are 2.1 and 2.3. But once you get into this TSV, through silicon via, by the way, whether it's a passive interposer or active interposer, this is where, to me, the real advanced packaging is. Okay, but let's keep to this. All this from 2D onwards using substrate, flip chip, that's advanced packaging, right? Okay. So this is another kind of definition by Yole, okay, putting all the advanced packaging platforms here. You will see, as I have mentioned, okay, they're all flip chip technologies using IC substrates instead of lead frame. Okay, but there are some possible hybrid flip chip and wire bond together. Okay, and typically it's fan out, but Yole has put in fan in as defined as one of them. So we have fan out packaging, fan in packaging, system in package. This is the bread and butter of Inari, right? System in package, flip chip BGA, flip chip CSP, also part of our line. And actually we are working on 2.5D. 3D will be a rather big challenge. Okay, I'll explain this. But 2.5D is possible, so we are also working on this. And as you can see here, as in Yole's definition, multi-die, flip chip, IC substrate, fan in or fan out RDL. Okay, just now I talked about 3D. I think many of us in the industry would know 3D stacking, you know, up to 16 stack. I remember more than 10 years ago, it was done. So no big deal. But those days when we did the stacking, it was wire bond. So like this type A. So based on just now what I've spent a lot of time trying to explain, right? So if you have a wire bond purely, then we do not consider this as advanced packaging. So you do need to have at least a hybrid flip chip. Another flip chip in this format, or a total flip chip in this format. Okay. So, but like in John Lau's definition, this is 3D IC packaging. Okay. This 3D IC packaging, including those so-called traditional stacking 3D, okay, do not use TSV, right? So this TSV is a true silicon via that is really used in the current advanced packaging. As you can see in this A here, this is a HBM, hybrid bonding, meaning you actually stack the memory. Why? In fact, this is kind of the first group of devices that go into hybrid bonding, into stacking for this 3D IC integration. Why? Because all these DRAMs, they are basically look-alike. So you can stack them. And if you want to connect them, you just make a true silicon via and some RDL, you can stack them because they are look-alike, right? Unlike some other stacking, which involves, example, logic and memory, that gets a little bit more complicated because they are not look-alike. So hybrid bonding and 3D integration using TSV has been around some time, especially if you go to websites like the memory makers, Samsung, right? SK Hynix, you see that. But now for the logic side, GPU, the XPUs, you go look at the breakdown analysis for NVIDIA and all this, AMD, you will see this being used. And that's where the difficulty comes. Okay, when we talk about 2.5D, we actually, 2.5D, they are passive interposer. So we can actually work with the fabs and just look at making the through hole and plating them and so on. But in the case of the 3D advanced packaging, TSV type, you need to do it on the like CPUs or logic. So you actually need to do it in the advanced fab, right? Nevertheless, this is something we aim for. Okay, maybe we get the chance, we get the CPU and see how we can make this TSV. But we will actually focus our energy now on the 2.5D. Okay, that's about 3D and how we differentiate between the so-called no TSV and the TSV 3D. Okay, back on the market. Okay, again from my good friend, from Yo. As you can see here, this is talking about the advanced versus traditional technology. So in orange, you can see the number of units, 1.1 trillion ship out in 2022, right? And out of that, only 6% are considered advanced packaging. 6%. Okay, we say it's growing and growing. Everybody says it's growing, right? But look at that. In 2028, Yo is forecasting 5%, a reduction in the number of units. Why is it shrinking? Because if you know the nature of this advanced packaging, actually they are talking about very big from the system of on chip, right? Partitioning down. So you need very big interposer, very big chip, and so on. So we are talking about very big devices and chip. So these packages are therefore very big, right? So we are seeing actually a growth in the number of the smaller packages versus the advanced packaging, which is actually much bigger package. Let's look at another number, right? This number is now about the value of it. Look at the revenue. Okay, in 2022, okay, 53% is from the traditional packaging, while already the advanced packaging is contributing 47%, even though it was only 6% in volume. And when it's 5% in volume in the next 4 years, right? It actually has grown to 55% in the market share in terms of revenue. That's the growth. Look at it. It's actually almost double in terms of revenue. Yeah. So how do we do it? How do we do it? I need to rush up a bit. So enabling technology, right? So what are of course there are many enabling technology, but from packaging side, I have just picked a few here. One, as I mentioned in the definition, as you can see, is flip chip bumping and bonding. So flip chip, example, the C4 and the C2. So this is the reason why I think Inari has some potential, because that's our bread and butter, right? Doing flip chip. And another, so if anyone who is really interested, maybe you can talk to me about this flip chip offline. But next is the hybrid bonding. That's the one I talk about for the HBM memory. That you have to talk to the Samsung of the world, right? But anyhow, the concept is not too difficult, I think, for many of the academicians here, right? Basically, you put the silicon together, like I said, you know, the memory, two memory, identical die, like what you see here. And then you bond them together, but now you not just have to bond the metal, you have to bond the oxide. So how do you just put some, okay, yeah, put them together at a low temperature and some pressure, and then you anneal it. When you anneal the metal, the copper especially, has a higher CTE, we know, versus the oxide and silicon, right? So the metal will actually expand. And this is the internal pressure that the metal sees. And that's where the intermetal diffusion happens, and that's how it's bonded. So not so difficult theory, but in practice, this is a challenge, right? So the cleanliness, the accuracy, placement accuracy, and the bonding pressure, and so on. So another enabling technology, packaging substrate. I saw some ATNS, and also, of course, from the fab side on the silicon interposer. This is where we really have to go down the line and space width to meet the tighter and tighter space requirement, right? So for the low end, we can actually, like in the advanced packaging still, as I have defined here, 2.3D, 2.3D, 2.1D, you can still use the colorless substrate. Okay, but what happens when, as I mentioned, when you go into 2.5D and above, the die gets bigger and bigger, more functionality on the interposer. So you cannot depend anymore on a colorless substrate like this. You have to go into silicon, where the expansion rate CTE matches with the silicon, right? So that's where TSV, RDL, silicon interposer becomes more important. And lastly, but not least, is the design software and techniques, right? With advanced packaging, we are packing trillions of transistors in the near future into a similar area, a small area, right? So like what Keysight's Muth said, it is multidisciplinary. You cannot just have a standalone design. And after you have designed, you just chuck it to the fab. And after the fab has designed, just dump it to the assembly house. No. We have to look at all the issues that can happen in this and make right from the start, right? So how do you manage all this complexity? Basically, in a simple explanation, right? That if you look at all the complexity, actually, IC design really has to be integrated into the manufacturing flow and not as a standalone. And then when things get too difficult, okay, some of us may not believe so much in the ChatGPT, right? But AI is still storming the world, right? And in the factories, we do depend very much on AI and automation. Similarly, I think in the designing and so on, we have to look into all this automation and AI. Okay, so very quickly, so we need all the thin film processing technology, flip chip technology, and advanced packaging to really make things work. Yeah, so yeah, this is what we are working on, 2.5D in a tri-party arrangement. So I'll talk more about this later in the, I guess, question and answer session. So, but I think a lot of challenges in advanced packaging. Basically, if you look at man, we need the talent and the talent pool and matching skill, okay, in terms of quantity and quality. And then machine, huge capital investment required. Method, R&D, knowledge, know-how, IP, right? Material, we need all the ready supplies nearby us, especially. Environment, good geopolitical stability, policies, incentives, and so on. So do we have all this in Penang, in Malaysia? That's something that we can talk about in the panel. Thank you very much.
Thank you, Suha. That's an insightful presentation, and I hope that it brings all of us to some kind of understanding from all the way from the basic to the advanced packaging in that sense. Because whenever I speak advanced packaging, I get a different variations of advanced packaging. That's very good. And I always talk about something sarcastically called from PowerPoint to reality. You know what I mean? When Suha presented that, it looks pretty straightforward, but it's so complex in terms of manufacturing. But as human beings, we've been able to advance ourselves. And that leads me to the next presenter because she talked about advanced materials. Yeah. So the next presenter is Dr. Lee Hing Wah. He is the head of semiconductor R&D at MIMOS with more than 19 years of experience, holding a PhD in mechanical engineering, specializing in MEMS from University of Sciences Malaysia. Both of them are alumni USM. MySTIE, are you? Oh yeah, all right. Okay. His expertise spans semiconductor technologies like advanced packaging and AI devices. Dr. Lee's focus includes nanomaterials, incorporating them into MEMS and NEMS. I'm not so sure about that, but you can explain what that is. And for sensor applications. With over 50 patents and numerous publications, he is a leading figure in the field. Dr. Lee chairs the National Committees on Nanotechnology and Wearable Electronics, shaping the policy, and is also recognized as a professional technologist for his significant contributions. With that, please, Dr. Lee, let's listen to him in the area of new materials for sustainable semiconductors. Thank you.
Okay, a very good morning to everyone. So first of all, I would like to thank Dr. Hari for a very kind introduction. Thank you, Madam Swiha, also for a very insightful sharing session just now, and also to our fellow panelists, Puan MySTIE. Obviously, I would like to thank ASM for inviting us into this very great sharing forum, and also NCIA for providing the venue to this, and also to all the audiences for your attendance and attention. Okay, so today I'm going to share some information on new material for sustainable semiconductor. So I'm going to talk a little bit on material. Probably is a very boring subject for most of you because it involves a lot of chemistry and physics. And I hope you'll be able to get more information and understand better the importance of materials in the semiconductor value chain after this presentation. Okay, so this is the snapshot of my presentation today. So first of all, I'm going to probably explain a little bit the importance of materials in the semiconductor value chain. And after that, I'm going to share also a little bit on the perspective on the importance of having a sustainable semiconductor. And after that, I'm going to share a little bit on Okay, sorry for the technical issue. I'm sure it's not a material issue. Okay, so moving forward, I'm going to share some new materials. Okay, that is very highly researched currently in the semiconductor industry, and sharing some perspective in terms of this prospect and also the motivation of utilizing this material in this industry. So I'll end this presentation with a summary of the talk. Okay, so first of all, let's move into the importance of material in the semiconductor value chain. So I think if you look at this figure, I think it's very common in a lot of those snapshots in terms of the semiconductor value chain, and we can see where material plays a role. Okay, so basically they will talk about having material supplying into the fabrication process flow and also being used extensively in assembly, test, and packaging. But I started off my career, a research career in modeling and simulation. So I can tell you that in the design aspect also, a lot of materials are being used in consideration because you have to put in all the material properties for the simulation and also the design. And when you do optimization, so being a young researcher at the time, you always try to do some customization and plug in some imaginary numbers, okay, and to see what are the properties that could enhance the device performance to its ultimate level, okay, and that is where those properties led to the discovery and development of new materials being incorporated, okay. So that's why a lot of those engineers will try to discover new material that meets all these property. Okay, so if you look at the market share of material supply in the semiconductor industry, so you'll be surprised to know that East Asia, okay, has a 57% share of the material market share. Okay, if you incorporate China, so basically Asia is a powerhouse, okay, in terms of material supplies to the semiconductor industry. So due to the recent geopolitical tension, the US chip act, etc., a lot of attention are being talked about in terms of the supply or the restriction of the supply of the DUV or EUV equipment from ASML to the China. Okay, so but not many people talk about the material that is being used, okay, for these DUV or EUV processes. Okay, so if you have a look, so basically the material is very important and is being dominated by the East Asian country, as mentioned earlier. For example, from the Japanese, so like companies such as Tokyo, Ohio, JSR, etc. They probably dominate 75% of the photoresist supply to these companies. Okay, so it's a very huge market domination, and because of this US Chip Act and the geopolitical tension as well, China, due to its self-sufficiency and trying to be independent, so they have also tried to push in a lot of investment in this area, and a lot of new company has emerged out of that. So for the first thing that we want to talk about is basically in Malaysia, we don't have a lot of prominent local material suppliers. I think nearby here, okay. So in nearby here, I think we have a very good material supply company such as MySTIE Technologies very near here, and I think we need to start growing more companies in this area as well. So what does this tells us? So how do we grow these companies in this area? So probably like what our ASM president mentioned earlier, Dr. Teguh Azman, we probably need some abnormality or chaos. Probably Malaysia need a sanction for us to probably grow and put an emphasis on these material companies. Okay. So during my study in USM also, this is a very important period during my postgraduate studies. Okay, so 2003 and 2006, I see a lot of young engineers here. So maybe you're not aware of these dates. So I think probably the veterans in the semiconductor industry will know this date. Very important date. What is this date about? So basically, this is when the lead-free became a law in US, and the implementation date is on 2006. So during that time, I saw a lot of MNCs coming over to my professors seeking help. So I was like astonished. So how come suddenly there's a big hoo-ha in our research lab? So a lot of MNCs come to our professors, late professors lab to seek help to do some simulation on the reliability of lead-free solder. Okay, so this is because lead-free solder is being implemented, is being made law in 2003, and the implementation 3 years of implementation. So they have some 3 years of time frame to develop new materials to support that. So lead-free is not something new. I think in 1970, US formed the Environmental Protection Agency. So they already banned lead in a lot of products. Okay, but okay, you see, electronic products were exempted. So nothing much happened. People don't pay attention to it. So now, when lead-free became a law in EU, so US also were forced to follow suit. So a lot of people are establishing new standards, and if you want to develop new materials, you probably need to comply with all these standards to be used in the semiconductor industry. Okay, so you see from there, you see the emergence of a lot of new materials that came up from this legislation. Okay, so basically they are replacing lead with other materials such as silver, bismuth, stainum, etc. So there's a lot of new discovery of materials, and it's always the question of, is lead-free better? Okay, I think during my time also, John now, as mentioned by Madam Suya, came to Malaysia, and he's giving a lot of thought extensively, okay, because he's an IEEE fellow about this topic, okay. So is lead-free better? So a lot of people keep asking, is lead-free better? But if you look at from the technical standpoint, okay, there's always the issue with thin whisker on the solder. Previously, people solved this issue by introducing lead in solder. So ironically, people introduced lead to solve this issue. But now, because of the ban, so they have to remove the lead or reduce the composition of the lead, and this issue keep cropping up. Okay, so from the technical standpoint, is another new challenge. So they have to find new methods and material to improve further. Okay, so when you don't use lead, basically the solder also has to work in a higher melting point. And obviously, when you ramp up the temperature, so it always comes with additional costs, and also the reliability, etc., will suffer as well. So everything goes up in terms of cost and performance. Okay, and also there's other issues such as faster cooling, so the joint will crack, and also there's a poor wettability. Okay, so it's very challenges to use this for solder purposes. Okay, so if you talk about from the technical standpoint, maybe not. Okay, lead-free maybe is not a very good solution in the technical standpoint. But from the other aspect, why do you want to introduce lead-free? Basically, if you look at the benefits of lead-free solder, so most of them talk about the benefits to the environment, health, etc. Not too many in terms of technical advantages, but obviously researchers have done a rather good job to improve further. Okay, so why do we still want to use lead-free? So basically, legislation is the key motivation here. Okay, so for a better environment, health, safety, and for the better of mankind, so we have no choice but to introduce lead-free, and it's for the better of mankind. So the first point that I want to talk about, obviously, legislation is obviously the easiest and best driving factor, okay, to force people to use material for sustainability. Okay, so when you talk about the perspective on sustainable semiconductor, so there are a lot of different approach. Okay, for example, the first thing that I mentioned earlier, the easiest one is to just force the manufacturer to comply. Okay, introduce a new law, for example, the restriction of hazardous substance by the EU, and now because we are also signed the Paris Climate Agreement, we need to reduce carbon footprint, etc. Net zero. Okay, and Malaysia also has stepped up the effort to introduce national energy transition roadmap, and also in the new industrial master plan, I think the Mission 3 also will talk a lot about this. I think Puas Masni will cover some of it later. Okay. So the second part will be on in terms of the infrastructure. Okay, obviously the process step emission, we will try to reduce hazardous gas in the process and also the byproduct of it. And obviously, like for example, the energy supply optimization, process control, and also the wafer fab abatement. So in MIMOS, we also have like a MySTIE solution. Okay, it's a product where we have an autonomous chiller control for energy efficiency, where we introduce into our fab that give 10 to 20% of energy efficiency improvement. Okay, by using these IoT connected devices, smart devices to control the energy usage. Okay, but today I'm not going to talk a lot on the legislation on and infrastructure because our topic will be focused more in terms of the new materials. Okay, introduction into semiconductor industry for sustainability. So obviously the first thing is on the advancement in material technologies. So ideally, if we can use green materials such as leaf to build our chip, that would be ideal situation. So we don't need to spend so much on our material, energy, etc. to build a chip. So the first approach is always to use sustainable or green material, okay, to develop this chip. Okay, the second motivation is obviously if the material provides a great performance enhancement, this will motivate the semiconductor industry to adopt it. Okay, so for example, in this picture, you can see like 2D TMD material, transition metal dicarboxygenide, okay, which is very similar in terms of properties to silicon, and a lot of researches are being done to replace silicon with all these 2D nanomaterial. Okay, last but not least is obviously the trade-off is obviously the cost. So if you can find a substitute material that costs significantly lower than what you're using right now, so the industry will adopt it. So I think in terms of the approach of introducing new material, these are the three main considerations. Okay, so next I'm going to talk about a little bit on the new material that is being introduced in the market. So like I mentioned, so we can start with introducing green materials for the semiconductor. So one of it, I think, is being used extensively right now. Also, introducing using organic semiconductors. Okay, so it probably there are two main types of organic semiconductor. So the first type is basically the low molecular weight materials, so organic mono, or the polymer types of materials. Okay, so I think a lot of research are being done to use organic material on transistors, for example, pentacene-based organic TFT. And in the industry, obviously, I think most of you are aware, OLED so common already. Okay, polyfluorenes, for example, is basically the very popular material because it is a polymer of family of polymer that can support all the visible light spectrum at a very low operating voltage. Okay, and also the oligomer counterpart ALQ3. So a lot of new work has been done to do this all organic LED. Okay, so it gives at the same time it gives a lot of benefits such as lightweight, low cost production, low temperature processing, soft and abundant availability. So all these organic types of material can also be used in various types of substrate and can be used in large substrate as well. So this also give a lot of advantage in terms of the application. Okay, moving to those wearable devices, disposable electronic, etc. Okay, but the challenges remain. So it's always not so stable and the lifetime is always shorter. So scientists have still a lot of work to improve further, okay, in terms of the stability and lifetime of this organic material. So you can read more at PatsNet. Okay, they share a lot of tables and properties, etc., discussing on this aspect. Okay, the next that we want to discuss is basically using superior material, for example, to meet the demand of consumer. So consumer probably wants faster devices, more powerful devices, but at the same time, low power consumption. So one of the material that comes to mind is probably silicon carbide and GaN, wide bandgap materials. I think right now it's very popular. You see Infineon investing extensively to build new fabs on SiC. Okay, because it provides wide bandgaps solution to the power hungry and also faster switching application that is being used a lot in new emerging industries such as EVs, renewable energy, solar, high performance computing, etc. So whenever we talk about energy efficiency and also to have a fast switching rate, so we talk about wide bandgap material and silicon carbide and GaN comes into mind. Okay, so these are basically the advantage of using GaN and silicon carbide. Okay, and last but not least, if we can complement with smaller materials, so when you talk about using smaller material, basically the consumption of the material is also less. Okay, and also, for example, when you have smaller material, obviously the distance for the electron to transport is also less. So obviously you give a better performance. So that's when you can probably use 2D nanomaterials, and graphite is basically an example of 2D nanomaterial that has very good properties, and it is one of the focus area of Malaysia as well. It is in the advanced material roadmap, and it is also in the NIMP 2030. Okay, so it gave a lot of gained a lot of popularity when graphene experiment was awarded the Nobel Prize in 2010. Okay, by Professor Konstantin Andrew Grime and Konstantin Novoselo. So it is the single layer graphene is deemed as the thinnest, most transparent, strongest, flexible, fastest, and best conductor. So it's a wonder material. So such a great property. But obviously, in practical usage, a lot of challenges comes into mind. Okay, and a potential for Malaysia in this aspect in terms of graphene material is that we have a lot of oil palm in Malaysia, and one of the things that we can use is the waste through palm kernel shell, for example, because to synthesize graphene you need a carbon source material. So there's a two method here. So you can use methane, okay, byproduct from burning all these palm kernel shell, to feed it into a wafer for CVD, chemical vapor deposition process, and basically you can grow graphene on the substrate. So this is something that we have actually done in VMOS. So we have managed to grow graphene on silicon wafer. But unfortunately, in Malaysia, we don't have a local wafer fab who can take it out. So I think when we introduced this technology in 2017, I think in Europe, it came to their attention and they bought a similar equation and developed a similar technology, and now they are supplying to the rest of Europe on these graphene wafers. Or the second approach is basically just to use this palm kernel shell to make graphite. Okay, and then you can, from the graphite, you can just use pyrolysis method, for example, chemically derived method to make graphene. Okay, and then when using graphene in our lab, so we see that less demand on the graphene on silicon wafer. So now we are developing our chemically derived graphene conductive ink as well as a replacement for metal that is being used in a lot of the semiconductor industries. So I think this is something that we will work very closely with Inari as well, probably to develop nanomaterial based solder or filling. Okay, material. So we have a lot of graphene based conductive ink material, and this is a local technology, and basically you have the capability to tune the material for anti-static property, transparent property, or even UV curable types of properties. So all these are available on our website, this technology. So we managed to develop our homegrown technology in this area, okay, for the next generation wearables and flexible electronics application. Okay, so there are other emerging nanomaterials that is being considered. For example, in the solar, so a lot of people are working on perovskite. So perovskite solar-based solar are still a lot lab-based. So now we are working with UKM to develop metal-free halide perovskite, lab-free types of perovskite material. So we are also working with University of Nottingham of Malaysia to try to derive conductive ink using boraphene. So boraphene is similar to graphene. It is also a single layer of boron atoms. Graphene is a single layer of carbon atom. And obviously, another emerging material that has gained a lot of attention is the MaxScenes. Okay, so this one we are working very closely with our counterparts from Sunway University Malaysia. Okay, so these are all emerging new material that could be considered for adoption in the semiconductor industry. Okay, so as a summary, so just now we talked about sustainability. So I think the ESG team is very well alive, and it's very important, especially not only to the government but also to the companies in terms of the branding, etc. So now a lot of business deal also involve ESG score. So I think they are very keen to adopt this. In semiconductor, the aspiration is towards green IC industry or green energy. So this shift is driven by the need to reduce carbon emission, combat climate change, and create more environmentally friendly manufacturing process and facilities. So like we mentioned earlier, so it might not be the best in terms of technical or performance, but sometimes it has to be done. So we need to introduce some of this environmental friendly material into the semiconductor industry. Okay, so how can we convince the industry to adopt this sustainable material? So we also discussed. So the easiest mean is through legislation, law. So luckily, I think more people have a better awareness in terms of the safety of the planet, for example, environmental concern. So now not many people are complaining when there's a law enacted for this effort. Obviously, the second one is basically the performance. So if you have a very outstanding material that outperforms a lot of conventional material, although it costs more, probably it will be considered for adoption in niche high-end application as well. So these are also another consideration. And last but not least is obviously the cost. Okay, so if you have a material that costs less than what is being used right now and it performs similarly, obviously that will be the material of choice that can be used to replace whatever that is being used right now. Okay, so in terms of the Malaysian context, so we are committed to a sustainable industrial future to policies such as NIP 2030, New Energy Transition Roadmap, E&E Roadmap, and Advanced Material Roadmap. All these talk about sustainability and new material introduction for sustainable environment. Okay, so obviously, so we need the help and cooperation of everybody to realize this. Okay, so that's all for my presentation today. Thank you very much.
Thank you, thank you, Lee, for the informative presentation. And you talked about legislation just now, so that well dovetails to the next presenter. We have Miss Masni Muhammad from MIDA. She graduated with a Bachelor of Chemical Engineering from the University of Malaya and has over 22 years of experience in MIDA, currently serving as Executive Director of Investment Policy Advocacy in Manufacturing. Yeah, that's what it says. She has worked across various divisions, including petrochemical industry, chemical, advanced materials, oil and gas, and also maritime technology, and also strategic planning and policy advocacy, especially in manufacturing. And she now leads the Investment Policy Advocacy Manufacturing Division. In her current role, Masli is responsible for formulating policies, strategic planning, and coordinating investment-related initiatives to develop Malaysia's manufacturing sector, including facilitating international cooperation and preparing key reports for government announcements. With that, Ms. Masni will enlighten us on the topic of robust policy frameworks to catalyze the role of semiconductors in green transition. Thank you, Ms. Masni.
Okay. Thank you, Dr. Hari, for that kind introduction. I feel so small today in the presence of scientists, technologists, academicians. But then thank you to Academic Science for inviting MIDA to share our view at this Tech Talk on semiconductor industry. Okay, so we have seen firm level, project level presentation, 3,000 feet kind of presentations. I'll bring you up to 30,000 kind of feet at macro level. Some government's aspirations in terms of energy transition, government policy, government intervention, including government facilitations to encourage green adoption. All right. Yes. All right. For benefit of those who are not familiar with MIDA, just a short introduction. We were established in 1967, so we are proud to say that we have be part of the shaping of Malaysia's industrial landscape way back in the 1960s, where the policy at that time was import substitution to focusing on resource-based palm oil, including heavy industry way back in 1980s, to digital economy, IR4, and industry-forward e-commerce today. Our services, of course, we are known as investment promotion agency. We go around the country, we go around the world, knocking people's door and say, look, look at Malaysia and invest in our country. So that is what we do. People know us for that. But at the same time, we provide or we give approvals for licenses, for permits, for tax incentive, for duty exemptions, talent requirement. And for item 3, this is something that the government of the day is focusing on. They want to make sure that whatever that we approve under item 2 or whatever the government announced in the news are realized and implemented so that the rakyat will feel the benefit, get the spillover, and move forward, as a country. And of course, we don't stop there. We will continue to facilitate our investor, whatever their needs are, whether they need people, they need sourcing of inputs, their raw material, their components, their machinery, whatever issues. Sometimes I tell my officer, longkang tersumbat pun we have to assist our investor to that extent, because we notice that based on our data, historical data, more than 50%, almost 60% of our investment approved comes from brownfield, and meaning that from investors who are happy to be here, making profit, expanding their business continuously over the years. So that's the reason why item 4 is also equally important. All right, so this is the reason why we continue to engage academic science, the industry, talk to people in the technology space, because we need to scan all this. It is very important for MySTIE because this is how we identify investment opportunities. We want to ensure that the project or the sector that we are target is in line with the future of the world, future of our country. Okay, and at the same time, we also want to attract the right investor. Right? We don't want to attract the wrong investor. We want to attract the right investor who are aligned with whatever Malaysia can offer, aligned to our strength, and aligned with our economic agenda. All right? And with this, we develop our promotion strategy, where we want to go, which country, which sector. So this is important. And by doing all this, we will ensure that our economy will be foolproof, meaning that we are ready to grow in the future as we are aligned with all these emerging technologies. For example, currently we are looking at silver economy. We are already classified as aging nation. Okay, Malaysia is already an aging nation. So we need sector that is related to elderly care, medication for elderly people, the services, the infrastructure. So that is one area. We're also looking at IR4. We're looking at digital economy. That's another area. And also we are looking at climate action investment. Okay, people talk about sustainability, ESG, green transition. So that's another area of investment opportunity that we're currently looking at. So MySTIE is currently promoting Malaysia as the premier investment destination for sustainable FDI. So that is the theme, okay? The theme at the national level. Because we understand as the global is more aware of sustainability agenda, of greening or protecting the planet, we know that this is changing how investor makes decisions. That's why we have put forward this strategy to guide the whole nation towards this strategy by making sure or supporting our industry to minimize carbon footprint, including semiconductor. Because we have a certain sector that are emitting a big volume of harmful gases. So we need to support them to minimize their carbon footprint. We are building resilience against carbon pricing mechanism affecting our trade. As you are fully aware, Malaysia is a big trading nation. Our trade to GDP is 140%. So if anything happens to our trade, it will affect our growth. So we need to prepare our industry so that they are ready for some of these carbon pricing mechanism. For example, in the Europe, they're introducing this carbon border adjustment mechanism. If you don't do anything about it, in the next few years, we will start losing our market in the Europe. Okay? And of course, like I mentioned earlier, we ourselves need to embrace this green economy to improve our attractiveness as as a green investment destination. And we have put all the policy support, which I will elaborate later in my other slides. Okay, this is our new industry master plan, 2030, launched last year, September, focusing on 4 missions: advancing economic complexity, move up the value chain. We no longer want to produce toys, for example. We want to produce robots. So that's a simple analogy. Tech up, of course, we need to automate some of our processes. Some of our SMB are still reliant on foreign low-skilled worker. So we need to tech up, automate using IR4, AI, and all those technology. Mission 3, very relevant to what we are discussing today, push for net zero, meaning that we want to achieve net carbon emission by 2050. Mission 4, inclusivity. This is where we want to ensure that everyone is on board, whether they are in Sabah, whether they're in Sarawak, Eastern Corridor, whether they are SMEs, micro enterprises. So what we're saying here that we pay attention to everyone, not just multinationals, not just FDI. So we have a robust green tech ecosystem. We are ranked first place in Southeast Asia in terms of energy transition index. When we look at the report, our strength is actually the government has a strong commitment towards green transition. So meaning that we have all the policy framework, like what mentioned by Dr. Tengku earlier. We are not short of a good policy. Okay, the execution is the issue. I agree with that. Anyway, we are ranked first because we have that. We have a strong commitment, strong vision by the government, and we have made progress in terms of production of renewables. I remember our incentive, GITE, was introduced in the early 2000. We started very much earlier in terms of renewables. Okay, so we are there. But of course, we need to continue to move forward and improve some of our policy. We have strong policy. We have put in place energy program. We have tax incentive, funding also. We are quite strong in terms of financing, green financing offered by Bank Negara, our commercial bank, and so on. For MIDA, these are some of the incentives that are already there. You can just Google and visit our website. Production of renewable energy, there's incentive for it. From biomass, from solar, from wind, everything, including hydrogen. Yeah. Production renewable energy for sale, as well as production of renewable energy for own consumption. We incentivize both. Adoption of energy efficient equipment, purchase of energy efficient equipment for your own consumption. We incentivize. Development of integrated waste management, production of green product, for example, biodegradable plastic packaging, for example, is promoted. Or production of value-added product from biomass, palm kernel oil, graphene from palm kernel. Earlier we saw in the earlier presentation is something that we provide incentive. EEV, of course, announced last year. Green certification, green building, green data center, okay, sustainable data center, as well as green township services. So these are some of the incentives that MIDA offer. At the same time, we work with United Nations in identifying what are the priority sector and investment opportunities areas that our investor can invest in. But this is not only for green transition. If you see, this is actually in line with the country's sustainable agenda at national level. So you see healthcare, you see financial, but of course, a big chunk of the investment opportunity areas are in the green transition, right? E&E sector, all right. I think many of us are familiar with these slides. So E&E sector is crucial or very important to our economy in terms of its contribution to GDP, contribution to export market. It's also every year in and out, E&E sector will always be at the top of the recipient of FDI. Why? Because we have strong ecosystem. Yeah. So that is the contribution of E&E. But moving forward, the industry needs to move along with the national agenda of green transition. Number one, because we have an agenda to be net zero by 2050. Two, if we don't do anything, we lose our market. We won't be able to supply to the 60 plus multinationals. I'm very sure those multinationals have their own commitment. By a certain number of years, they must ensure that they are green. So the 780 plus SME must also be on board and start moving towards this green transition agenda. So the way we see it, semiconductor is the brains of green transition. So semiconductor is the tools for all this technology for green transition, whether it's at national level or global level. This is how it is. This industry is the tools, is the driver, a significant driver for green transition agenda. So there's a big potential and importance there. That's the reason why the government established this task force headed by our very own YB Menteri, Kuzafrul, with participation of advisory panel and advisory industry experts from both local and multinational companies. It is very strategic semiconductor today because some people say it's the new oil. Yeah, people go to war because of oil those days. So it's equivalent to oil today. So in detail, we have a very attractive incentive. I think Minister of Finance won't like me showing this incentive. Up to 25 years of incentive, plus another 5 years of reinvestment, plus customized package incentive. So if you have utilized all 25 years, come and talk to Maida. We are definitely an avenue to have this customized package incentive. Of course, there'll be a ding-donging with the stakeholder, for example, Minister of Finance, Lembaga Hasil, but with correct narrative, with a priority sector in mind, we will be able to convince those in the committee. So another area of incentive that I just want to share, we have this domestic investment accelerator fund for domestic industry, mostly SMEs. We have foreign investment accelerator fund for multinationals. So have a look. We just launched this. The item number one, we just launched, I think, last week or 2 weeks ago. FIF is already launched a few months back. Special incentive location is going to expire this year, December. So have a look at our website to understand the process and the qualifying criteria. So this is my last slides. I'm very sure some of you are multinationals here. You have SME in your value chain, and based on feedback that we receive, most SME are not familiar or not aware what is ESG. Okay, so if you have a commitment that by a certain number of years you have to ensure that all your value chain are ESG compliant, this is something that your vendors need to look at. We provide up to 500,000 grant per company. This is after matching, meaning that the expenses that you will incur will be up to 1 million. We subsidize 500,000 for you to spend on costs related to validation, verification, certification of ESG practices adoption. Okay, so have a look at our website, and I think I will stop here. Thank you for your attention.
Thank you, MySTIE, for that highly informative presentation. It's interesting. I mean, I'm just listening and I learned a lot of stuff, although I've been around industry for a couple of years, but some of these were relatively new to me and highly informative. I hope that you found it informative too. We're kind of running a bit short of time. Are we able to extend it, or do we keep to time? We got 10 minutes for a panel discussion or a Q&A. maybe extend it a little bit more. It's open for questions from all of you, and I'm told that it's also going on live Facebook. So I guess the organizers will help me to check out what's in the Facebook if there are any questions. Yeah, but can I just open up for questions from the audience here? Anybody? Is there a mic going on?
Okay, thank you. I'm Fauzan from CRES. My question is very simple, but my elaboration is a bit long. Because this topic is innovation Kopitiam, so obviously we want to play the innovation game. So the question to each of you is, how do we play the game? But the problem is this. I'm going to position it as center of paradox. Okay? There is a couple of paradox in whatever you're saying. The East and the West paradox. Because the semiconductor is a game between East and the West. In the East, material companies like Japanese companies and whatever are leading. Fab companies are also in Korea and in Taiwan. They are the leadings. Equipment companies are European and Americans, very deep equipments. So that's the paradox we are playing. So whenever we're talking about packaging or material, Malaysia is always trapped between the paradox of an Eastern technology-driven ecosystem and a Western innovative pathfinding space. So how do we play that innovation being in the middle? So again, center of this paradox. The other paradox is packaging world is crossing between what used to be a play on the assembly is now a play of a fab, right? And the behavior to design packages is a bit IC design centric now rather than assembly centric. So again, how do we play this? The third paradox is, I heard the company like OSAT, like Inari, you know, I'm a good friend of Inari, but at the same time, I visited the best of the OSATs like Amcor ASE. And what do they do to make advanced packaging? It's earth-shattering because they discover the top of the technology and they go and find customers. We, in turn, we are actually waiting customer to drive our innovation. So slightly different way of playing the game. And many more. If we take equipment companies, all our equipment companies are either a vision system maker or a wafer handler or a chip handler. But not about bonding. We don't get any bonders made in Malaysia. So another paradox is equipment, we are playing on the tail end of the equipment. And all of these need advanced equipment, like the LAM research that just started. But local companies are very few in that, even though they're very successful. So, question is simple, but the situation I presented are complex. How do we play this innovation game in whatever you say?
Okay, maybe Suha can take that. Another mic.
Hello. So I think very good question, right? If I remember the description, basically, if we talk about the East and West and the geopolitical tension and so on, I think I'm sure Chris and many of us know, actually, we are the winner. So we are in the middle, East and West, right? So it's true that we do not have some of the technologies, but for many, many years, we have been leveraging the equipment from the, especially European and the US side, and also materials from the Japan and Korean side, right? But when I said, I think Malaysia, in terms of what I've seen, I don't think we lose anything in this East and West segregation. But we are winning. Why? Because I would say like maybe 7 out of 10 customers that come to us now are really because of the geopolitical tension that we are seeing in the between US and China. So many companies are looking out of China, and we in Malaysia are actually benefiting, right? So in terms of innovation, yes, I think a lot of things we are in the tail end. As I mentioned in the talk just now too, yes, advanced packaging, it depends on how you define it too. Well, Inari, even in Inari, we are not like a big MNC, but we are still rather big in Malaysia. We are in maybe 5 out of the 7 that I shared in terms of advanced packaging. So I'm going into the 2.5D and 3D. As I said, 3D, yes, Fauzan, you're right? 3D and even 2.5D, we are actually merging the assembly and packaging and the fab. So we are not very strong in the fab. But like Dr. Lee, right, from MIMOS, right? I'm actually working very closely with MIMOS. With the fab knowledge that they have, we can actually leverage each other and get the packaging and assembly as well as the fab together in a small way to develop what we can do for at least the 2.5D, right? So we need to take this baby step to
Okay.
reach.
Okay, I think the point Fauzan talks about paradox and it's complex. But let me just follow through a question to you, Zuha, that if you look at what you presented, you know, the worldwide situation that over the next couple of years, you know, it's going to hit 1 trillion. And by the way, one of the things that I also looked at from working with MSIA, for example. I think in 2020 through our E&E, I think specifically was about 500 B or something like that. And if you were to take the same kind of growth trend in globally, we would be at about 1.2 trillion ringgit by 2030 if we do all the right things. So the projection is very, very positive. Yeah. Whatever Fauzan said in terms of the paradox that we are in. But having said that, what do you think areas that we need to focus, double focus, in order to make sure that we are still winners and going on the linear projections you have? You can use my.
Yeah, as I see, right? Also, I mentioned like majority of the customers that we have been seeing, at least the past year, are really a result of the geopolitical tension between the big countries, right? So I think first thing to me is why are these companies coming to us in Malaysia, right? I think number one really is our country's policy. We are neutral. We are neither pro-China nor pro-US. We are in the middle. So having good policy definitely is very important, right? To get these customers to Malaysia, and therefore we can actually do this development, right? And secondly, of course, even if these customers come to us, many of them we cannot serve. So it's a chicken and egg situation, you know, the paradox that Fauzan mentioned, right? If we don't have the technology to offer, they'll just come and go, right? That's the reason why I've been working with Dr. Lee and MIMOS, that we must at least develop something fundamental and be able to show that, you know, we have that capability. And then we can go around and market and say, hey, we have actually developed this, you know, even though it's just a prototype. Okay, because customers, big customers like NVIDIA, AMD, and all this will not just come to you without any basic. Okay, so what I'm saying is, first thing is a policy. Second thing is actually really your strategy on how you want to attract these customers. So to me, I think actually we need to establish some basic technology for this advanced packaging.
Okay, thank you. Any questions from the participants? Yeah, go ahead,
Thank you. First of all, fantastic presentation by all. I also want to kind of say thank you, and I have respects for the biggest capitalized company in Malaysia, and that's Inari. So really pleased that that you are here. So one of the things that I saw in your slide, one that says the value of advanced packaging by 2028 is going to exceed normal packaging. So that for me was the biggest concern. Actually, maybe not for Inari because they're already so big. You have ways of making sure you continue to grow. But as a Penangite, after 15 years in Silicon Valley, I come back. I want to see Malaysia continue to grow in ways that have other companies growing too. Not only Inari, you know, you're already so big. So my question actually is that value of packaging. We as Malaysians need to find a way to capture that, as what J. Fauzan was saying. We have to find a way to make sure that value is kept in Malaysia in some way. Maybe other companies can be more innovative and develop, because that is data. Your friend Yol is the one presenting that and saying it's going to grow. My concern is Inari is capturing and doing whatever they can, but the real growth is somewhere else. I'm even worried if the real growth is in Vietnam. That would be really concerned. So my question actually is, do we know of other companies besides Inari, anywhere in Malaysia that is actually trying, may not be successful, trying, okay? And we're here to find them. We're here with ASM to help them. Some people don't need help, it's okay. But those who want help, that is the purpose of ASM. That's why the association is actually about how to help the rest, working with everybody. So that's my question. Thank you.
Maybe Masni, could you take that? Yeah, from a macro government.
If I answer that from the macro perspective, it comes back to the issue of whether the perception, whether the government is paying enough attention to the domestic player or not. So I think definitely, if I must phrase this properly so that I don't be sounding defensive. We do have sufficient program to facilitate our domestic investor, but definitely our outreach is not enough. That is the reason why I think collaborative effort between everyone, whether it's the MIDA, MITI, with academician, with MySTIE, with everyone. So sometimes we fail to recognize, or we fail to understand the potential of certain things. That's why we need, for example, academic science to explain to us, or domestic champion like Inari to explain to us the importance of emphasizing or amplifying certain segment of not only semiconductor value chain, but also other sector, so that we'll be able to bring it up to a high level and fully maximize that potential. So I think this event, needs to be continued in the future, so that we'll be able, for MIDA, our outreach will be better, and at the same time, all these potential that are not amplified enough reach people. Government representation like myself. That would be my answer. Yeah.
Can I say something? Yeah, short one, sorry. So actually that's a fantastic thing to do, because this is why ASM's here. That's why we're here. I think one of the things I saw in your presentation is how can MIDA encourage R&D investment. You have tax incentives for all kinds of other stuff. R&D is the one that we're talking about that is going to be the one that is going to kill us. If we don't have R&D, our future is gone. Let me repeat that. R&D is about your future. Improving capacity is about your present. Which one would you want? You need both. But if you don't do investment in R&D, nothing happens. So the best way of doing that, in my view, is to encourage every one of you to invest in R&D because you know what is best for your company in your business. The only problem is you don't want to have to take the risk. So the best way is to use the incentive mechanism that MySTIE already has to say, anybody who invests in R&D, you decide what you want. If you can prove that you have spent this money on R&D, we will give you 100% off. By the way, Singapore gives 150% off. That means if you pay R&D, I'm giving you extra money to do it. That's cheap money because it's tax. My suggestion. Thank you.
Okay.
Yeah,
You may
if
want to
I
comment
can-
on that.
If I can just respond a little bit on that. Okay. Under RMK 10, RMK 11, we used to have a big budget for R&D grants. Yeah? We provide grants to our local company to undertake R&D activity. I think many of SME, domestic company have benefited from those grants. As many are fully aware, we have a bit of financial space, flexibility at the moment. So grant is something that it's still there, okay? But of course the quantum is a bit smaller, but it's still there. But that is one point. The other point is we need to do R&D, the right R&D. Okay, that is another point that we have to ensure that we must make sure it happens. That's the reason why yesterday I had a discussion with Puan Azami that we're going to have a discussion linking the R&D approvals that we provide to Academic Science Malaysia. So we'll be linking the expertise in Academic Science Malaysia with the investment that we are creating in R&D space. For example, some of these multinationals, when we provide incentive, is not aware of this because we don't have people, but we impose them with the condition that they must collaborate with local university for their R&D activity. Okay, that is something that we will collaborate with the SM and make sure that whatever resource that we have, whether it's tax incentive, tax foregone, grants and everything, is spent on the right technology and on the right project. Okay.
Thank you, MySTIE. We are running short of time, and I've got probably a question for Lee because he's getting bored with nobody asking questions. But so I'll ask the question. But it's a bit of a combination of what you had presented and what I had thought about from a question perspective. Lee, if you look at it from a new semiconductor materials other than silicon-based, they're not really popular at this point in time, albeit they may have high potentials and so forth. So have you come across any success factors in that area? Kind of related to that is the fact that you talked about things like graphene, and graphene has been around for many, many years. My alma mater, University of Manchester, did some work in that when I was doing a PhD. So I think that one of the issues that we have is that how do you make sure that our strong inventions become innovative? I think that's where sometimes we're very good at, Masni talked about the same thing that's related, that we're very good at inventing, coming up new stuff, but we're not innovating. Innovating means bring the economy. So maybe two things, but you may want to answer that.
Okay, thank you, Dr. Hari. So I think in Malaysia we have a lot of research activities and also research output, but most of the time it doesn't rely into actual products or technology that can be carried forward in terms of manufacturability. So I think this is one of the issues. So I think in general sense, I think moving forward, most of the research that is being conducted in Malaysia, for example, has to work very closely with our industry partners. So it has to be something that is a industry-driven types of research, and this is to ensure that the industry players will take up that technology for their product offering as well. So I think, for example, when you talk about graphene, so when we first developed the graphene wafers, so in Malaysia, we don't have a local players in the fab, okay, that can take up that technology. And when you talk about the MNCs, who probably has the capability to take it up, but they won't do it over here in Malaysia because it's basically a manufacturing plant that is dedicated for a certain product offering. So I think this is also an issue that we need to have a look as well. So going back to the discussion earlier, so when we talk about incentive for the MNCs or the companies working with local universities in R&D activities, so at the same time we have to ask them as well, are you taking up those technology that has been developed by these local researchers, and have you acknowledged them? So over 50 years of experience in semiconductor industries, okay. Unfortunately, we don't see like a Malaysian semiconductor products or technology out in the global market yet. Although a lot of things happening and being done in Malaysia, obviously in Penang as well. So I think that is something that we need to look into. Okay, when we do research, we have to make sure that this is something that is scalable, that adhere to the manufacturing compliance, and the only thing that we can do is work very closely with our industry partners. So that's my advice.
Okay, thank you, Lee. And just to end, and I just wanted to say a few words. If you look at the NIP 2030, if you look, MySTIE presented all the missions and the focus areas. We are really on track in terms of the plan and the strategy. The question is that how do we? And Tunku just now earlier on was saying he presented to the government. This is how to. Then they asked, how do you do the how to? So I think that's where the challenge is, that we got to make sure that, I think from a government perspective, they got the right vision and aspiration to drive this industry or the whole economy. The question is that how do we make the why and the what happen? Yeah. With that, thank you to the panelists. I know we ran out of time. There are a lot of more questions, and I'm sure in the Facebook there are questions. I have a lot of questions too, but I think that the information that was presented today was highly informative, or is highly informative, highly useful for all of us to think about what we need to do to continue to advance semiconductor in this country. With that, thank you very much. Thank you. Thank you for the participants.
Thank you, Dr. Hari, for steering the conversation alongside our esteemed panel of experts. I am sure that everyone is enlightened by today's session. With that,